Hello students, this is lecture number 8 on differential calculus. In this lecture, we will discuss some examples based on Leibnitz's theorem. As you know, we have already discussed about Leibnitz's theorem and in lecture number 7, and we have already discussed two examples based on uh, Leibnitz's theorem. So let us continue. So example, if y is equal to tan inverse x, if we have y is equal to tan inverse x, then prove that yn at point 0, that is equal to 0 if n is even and minus 1 की power n minus 1 upon 2 into n minus 1 factorial if n is odd. So we have to find the nth derivative of the given function. So let us start. Given y is equal to tan inverse x, right? So y is equal to tan inverse x means y is a function of x. So we can also write this y as y of x, because y is a function of x, so we can write yx is equal to tan inverse x. So let this be equation number 1. Now differentiate equation 1 both side with respect to x. We get, now differentiate both side, we get y1x. We can simply write y1, or you can also write y1x. y1x, that is equal to 1 upon 1 plus x square, and let this be equation number 2. In this implies if we multiply it by 1 by x square, then we get 1 plus x square into y1x, that is equal to 1. Now differentiate above equation. This again, let this be 3, let this be star. So differentiate star both side with respect to x, we get, now 1 plus x square, you can take this to be first function, y1x to be second function, so we can write 1 plus x square into y1x. So derivative of y1x, again we differentiate, so we write y2x plus derivative of 1 plus x square, it is 2x, y1x is equal to 0. 0 means derivative of constant is 0. So this, let this be equation number 3. Now we have to find out the nth derivative. So when we find the nth derivative, even instead of taking this step, step number 3 or equation number 3, we can differentiate this. We can also use n time differentiation here. So no need to write this, let this be equation number 3 here. So because if we have to find out the second derivative, then it's okay. But because we have to find nth derivative, so we can take the nth derivative from equation number 3. So to find, now taking nth derivative by using Leibnitz's theorem, we get, now we can apply the Leibnitz's theorem. So now what we do, we can take y1x to be, we can take this to be a first function u, and this 1 plus x square to be v. So apply Leibnitz's theorem, we get nc0 y1 n time derivative. So y is already differentiate one time, derivative one time. So when we again differentiate this n time, so we get yn plus 1, yn plus 1 x. And second function v as it is means 1 plus x square plus nc1 y n minus 1. So y1 तो already y we have u is y1, so n minus 1 टाइम डेरिवेट करने का मतलब yn टाइम डेरिवेट, एंड 1 प्लस एक्स स्क्वायर, 1 प्लस एक्स स्क्वायर का डेरिवेटिव क्या होगा 2x प्लस nc2 yn minus 2 टाइम डेरिवेट, so we get yn minus 1 x and derivative of 2x is 2. सेकेंड स्टेप क्या है, उसके नेक्स्ट स्टेप क्या आएगा nc3, इसको एक बार वो डेरिवेट करेंगे, so we get yn minus 2 टाइम डेरिवेटिव into derivative of 2, that is 0, right? So yn minus 3 time derivative, this is yn minus 3 time derivative, and this is derivative of 2, that is 0. So all other term become 0, plus 0 plus 0 plus 0. So this is equal to nc0 is n 1 plus x square yn plus 1 at point x plus nc1 is n, so 2x is also there, so we can write 2nx into ynx plus nc2, so we can write n into n minus 1 upon 2 into yn minus 1 x into 2 plus 0 plus 0 plus 0, 0. So that is 1 plus x square into yn plus 1 at point x plus 2nx ynx plus 2 and 2 cancel out, so we can write n into n minus 1 ynx. So this is the nth derivative of equation number 3. Even we have find the nth derivative of the given function. Okay. So let this be equation number 4, or yeah, this be equation number 4. So put x is equal to 0, because we have to find yn 0. So we put x equal to 0 in equation 1, 2 and 4, we get. So this term is equal to, this implies this is equal to 0, and this implies this is equal to 0, and this implies this equal to 0. So we have these three equations, not equal to, but this implies. So when we put x equal to 0 in equation number 1, so y 0, that is tan inverse 0, and tan inverse 0 is 0. So y 0, we get y 0 is equal to tan inverse 0, and that is 0. So y1 0 is equal, y 0 equal to 0. Now what is y1 x? y1 0. So y1 0, we put x equal to 0 in equation number 2. So y1 0 is equal to 1 upon 1 plus 0 ka square, 1 upon 1, that is 1. So y1 0 is equal to 1. Now from equation number 4, when we put x equal to 0 from 4, put x equal to 0, so we get 1, yn plus 1, yn plus 1 at 0 plus 2nx. When x equal to 0, this whole term becomes 0. So next is plus n into n minus 1, yn 0, that is equal to 0. So this implies yn plus 1 at 0 is equal to minus n into n minus 1 into yn 0. So let this be equation number 5. Now we find the value of y0, y1 0, but for other values we use this relation. So putting n equal to 1, 2, 3 and so on in equation 4, we get what we get. Put n equal to 1, so we get y2 at 0, that is minus 1 into 1 minus 1 into y1 0. So 1 minus 1 is 0, so whole term becomes 0. So y2 0 equal to 0. Now put n equal to 2. So n equal to 1, n equal to 2, y3, 2 plus 1 3, y3 0, that is minus 2 into 2 minus 1, minus 2 into 2 minus 1 into y1, y2 at 0. And y2 0 is also equal to 0. So there is some, oh yes, this is not yn, this is yn minus 1, not yn. So this is yn minus 1. This is yn minus 1, and here also this is n minus 1. So when we put n equal to 1 here, so this is y0 means 0 the derivative. So I can write this is y0, because 1 minus 1 is 0, so whole term becomes 0. So here instead of 2, because we put n equal to 1, so we get y1, 2 minus 1, and y1 0 is equal to 1. So this is minus 2 into 1 into 1. So we can write minus 2 into 1 into. So I can write this as minus 1 ki power 1 into 2 into 1. And 2 into 1 as minus 1 ki power 1 into 2 factorial. Now come to n equal to 3. y40. y40 is equal to, put n equal to 3. So minus 3 into 3 minus 1 is 2 into y3 minus 1 2, y2 at 0. So this is minus 3 into 2 into y2 0. What is y2 0? That is 0. So whole term becomes 0. For n equal to 4, y5 0, that is equal to minus 4 into 3 into y 30, and y 30 is equal to minus 1 की power 1 into 2 factorial. So we have already minus 1 here. So I can write minus 1 की power 2 into 4 into 3 into 2 factorial. So that is nothing but 4 factorial. Minus 1 की power 2 into 4 factorial. Next, for n equal to 5, y60, that is equal to minus 5 into 4 into y40, and y40 equal to 0. So y6 equal to 0. So what we observe, all even term derivative are 0. So n equal to 6, y7 0, at 0 is equal to minus 7 into 6 into y5 at 0, and y5 at 0 is minus 1 ka square into 4 factorial. So it's not 7, it's n is 6. So we write 6 into 5. 6 into 5. So this is minus 1 ki power 3 into 6 factorial. 4 factorial is already there. So 5 into 6, then it becomes 6 factorial. Right? So now we generalize. Now in general, what we get? Yn at 0, that is equal to 0 if n is even, and now we find out the relation between this. Let us find the relation between y7 and this. When we take the seventh derivative, then we get minus 7 minus 1 ki power 3 into 6 factorial. When we take fifth derivative, and then we get minus 1 ka square into 4 factorial. So one thing is clear. When we take 7, then we get 6 factorial. When we take 5, then we get 4 factorial. When we take third derivative, then we get 2 factorial. So it means n minus 1 factorial. So n minus 1 factorial is here. One thing is clear. If we take the nth derivative, then we get n minus 1 factorial. Now come to minus 1 ki power this, because this term is not as simple. So 7, if we take 7 plus 1 by 2, then we get 8 by 2, so we get 4. That is not acceptable. So if we take 7 minus 1 by 2, then 6 by 2. So this is work for seventh derivative. Now come to fifth derivative. If we take 5 minus 1 by 2, so 5 minus 1 is 4, 4 by 2 is 2. Yes, this work. So we can take for nth derivative, we can take minus 1 ki power n minus 1 by 2 if n is odd. Right? So these are some questions based on this is very important question. These examples are based on Leibnitz's theorem. Go through this, and again, because this question is not simple. So if you go through the video and try to solve, then it will become easy. Now let us discuss one more example. We have already discussed this example in my previous video lecture. So y is equal to sine inverse x ka whole square. We have to find y nth derivative at point 0. So you quickly go through all these steps. We have already discussed these. So now come to equation number 3. So this is equation number 3. So now taking nth derivative, by using Leibnitz's theorem. We get, you can take y 2x to be u and 1 minus x square to be v. So we can apply NC0. y2. So we have already differentiated this function 2 times. When we differentiate n more times, so we get n plus 2 at x into 1 minus x square as it is. Why we take 1 minus x square to be v? Because this is vanishing function. After some steps, this function becomes 0. So that's why we take this function to be v plus nc1 yn plus 1 time derivative at point x. And now we differentiate 1 minus x square, we get minus 2x. And in third step, nc3 ynx, derivative of minus 2x is minus 2. And all other terms become 0. So there is no need to write other term. Now come to this point. Minus, so we can write minus here. And then curly bracket, we take y1 to be u, x to be v. Again apply Leibnitz'S theorem here. So nc0 y1 n time derivative, we get yn plus 1x and x as it is, plus nc1 y n time derivative and derivative of x is 1. And now all other term, because derivative of 1 is with 0. So now we don't write any terms after this. And derivative of 2 is 0. So this whole term is equal to 0. So rearrange this, combine the terms of yn plus 2, yn plus 1 and yn we get. So now I directly write the, after taking the common, combining the term, we can write 1 minus x square into yn plus 2 at point x minus 2n plus 1 into x into yn plus 1x at point x minus n square yn at point x, that is equal to 0. So this is our fourth equation. Now put n is equal to x is equal to 0 in equation 1, 2, 3 and 4 we get. So when we put x equal to 0 in equation number 1, so y0 is equal to sine inverse 0 ka whole square, and sine inverse 0 is equal to 0. So we get y0 equal to 0. So y0 is equal to 0. Now what is y1 at point 0? So for y1 we use equation number 2, put x equal to 0. So sine inverse 0 is 0 and other 1 upon under root 1 minus x square is 1. So this again we get y1 equal to 0. Now y2. For y2 we use equation number 3. So when we put x equal to 0, we get 1 minus 0 is 1. 1 into y2 0, that is y2 0. Minus 0 into something, this becomes 0. Minus 2 equal to 0. So this is equal to 2. So y2 0 equal to 2. y2 0, that is equal to 2. Now for other terms, we use equation number 4. Now put x equal to 0. So y1 minus 0 ka square. 1 minus 0 is 1. Yn plus 2 at 0. So I can write yn plus 2 at 0. Second term, because x is in multiple, so whole term becomes 0. So second middle term becomes 0. Minus n square into yn 0. So we can write this is equal to n square yn 0. But this result is applicable for n equal to 1, 2, 3 and so on. When we put n equal to 1, then we get y3. So we have already find y0, y1 0, y2 0. So now from this we find y3, y4, y5. Right? So this is important. We put in this box. Now put n equal to 1. For n equal to 1, y30. What is y30? That is, we put n equal to 1, not 3, right? So 1 ka square into y10. And what is y10? Y10 is equal to 0. So we get 0. For n equal to 2, y40 is equal to 2 square into y20. And y20 is equal to 2. So we can write 2 into 2 square. For n equal to 3, y50, that is equal to 3 ka square into y30. And y30 is equal to 0. So we get 0. For n equal to 4, y6 at 0, that is 4 ka square into y40. And y40 is equal to 2 into, so we can write 2 into 2 square into 4 square. Now for n equal to 5, y7 at 0. y7 at 0 is 5 ka square into y5 at 0, and that is equal to 0. For n equal to 6, y8 at 0. 8 means we put n equal to 6. So 6 square into y6 at 0. And y6 at 0 is this term. So we can write 2 into 2 square into 4 square into 6 square. Now, can we generalize this? Now, in general, what is yn at point 0? This is 0 if n is odd. If n is odd. And for even number, we get for 8 we get 2 into 2 square, 4 square, 6 square. So last term is 6. For 6 y60 we get 2 into 2 square, 4 square. Last term is 4. It means difference between derivative and last term is 2. 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2. So for nth term we have the difference between derivative and last term is n minus 2. So we can write 2 into 2 square, 4 square into 6 square into so on into n minus 2 whole square. This result is applicable for n is even if n is even but greater than 2. Because for y20 and we can write y20 is equal to 2 and y0 is equal to 0. So we have two separate results. Y0 is equal to 0 and y20 is equal to 2. So even we can also write for n equal to 2 here. Yeah. So you can also, if we put n equal to 2, we get 2 minus 2, 2 into 2 minus 2, 0 ka whole. Oh yeah, this becomes 0. Yes, yes. So we cannot write. So this result is not applicable for 2, but that's why we write separate y20 is equal to 2 and y0. So go through this result, and this is again an important result. So this question, example number 2, was asked in exam HPU CBCS 2022. So these type of examples are important as per examination point of view. So go through some examples like I have given some question in as assignment. Question number 1: if y is equal to e to the power m cos inverse x, then find yn 0. Question 2: if y is equal to e to the power a sin inverse x, then find yn 0. Try to solve these examples because these examples are based on that we have already discussed in this video lecture. Sometime question number 2 is also asked like this: if x is equal to sine of 1 by 2 x, then find y. So this is also important. 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 log y upon a, y upon a, then find y and z. So what you do when this question is asked, even you can also write this question number one similar to this type, right? So x is equal to this. What we do here, we take sine inverse both sides, so we can write sine inverse x is equal to log y upon a, or this implies log y is equal to a sine inverse x, a sine inverse x, or take antilog, then we get y is equal to e to the power a sine inverse x. So if question is asked in this type, in this way, then you have to convert this in the form of this. Then you can solve. So sometime examiner confuse the student. They are not asking the direct question. They ask in this way. So this is not a different question. You just try to rewrite, rearrange this, and then find y, and then after finding y, you can find the derivation. Okay? So similarly, you can try this question also. You try to write in other way, like this way. Okay, so I hope this lecture will be helpful to you. Try to solve the examples and questions in the similar exercise. Thank you.